Okay, hello. Today I'm going to be talking about magnetic variation. So let's go ahead and get started. I have Google Earth right here, and basically magnetic variation is easy to understand once you get the concept, but it's difficult for people to figure out why they need to incorporate that into their flight plan and how it exactly affects their flight. So I'll just go ahead and show you. Now, in my last video, we had already talked about how when you plot a course, you're going to get what's known as your true course. And your true course is just simply the line of reference, if you will, in relation to your geographical North Pole. So, like, for example, and we'll just do a quick review real quick. Let me get my little path tool up here. Let's just say I was going from Ellington Field, which I believe is right here, down to Galveston. We've already talked about how you're going to be on a true course of 144 degrees. And all that simply means is that you are simply 144 degrees clockwise from your geographical North Pole. But in the process of planning your flight, you just can't jump in your airplane and just fly, if you will, on a compass heading 144 and expect to get to Galveston. There are some things you're going to have to do this flight path, if you will, to get the compass heading, which is the eventual overall number that you want to head towards. So basically, this line right here is going to give you two basic nodes of information, if you will. It's going to give you direction and it's going to give you your distance. But you have to work with these numbers to get your eventual heading. So one of the things you have to do is do magnetic variation. So let's just go ahead and start with that. Okay, well, first of all, how are you going to figure out where your magnetic variation is? Well, you're going to have to look on your sectional chart. So I'll do that right now. I'll go ahead and load up my little sectional chart. Let me see. And it's around here somewhere. Here we go. And sectionals. And we'll load that up. And here we go. Okay, so as the sectional chart loads up, you can see that it can get a little busy, which is all right. I mean, that's why sometimes I choose to use these videos without using sectional charts. But what you're looking for primarily when you're trying to figure out what your magnetic variation is you're looking for these little magenta lines right here. And I'll point it out. Here's one right here, and here's another one. And as you see, as you go down your latitudes, I believe those are your latitudes, you'll run into more of them right here. And what these are known as your isogonic lines, and you just want to remember that isogonic line. And what they do is they simply mark your line of magnetic variation. So in this case, this isogonic line right here is going to have a variation of 3.5 degrees east. This isogonic line right here will have a magnetic variation of 3 degrees east, and so on and so forth. As you can see, this is 2.5 degrees, and they'll continue on until they eventually hit what's known as the line of zero variation, which is known as their agonic line. And then they'll continue on, except they'll start going into westerly variation. But I don't want to get too far yet. Let's just go ahead and stick with this line right here. So let's just say you're planning a flight and you are looking for your variation. Well, you're going to look for your closest isogonic line, if you will, which in this case, it looks like this is going to be our closest isogonic line right here. And you will use your 3.5 degrees variation to the east. Now, we all have the saying, east is least, west is best. And what we've learned from school is that if it is 3.5 degrees east, then you will subtract that from your true course to get your magnetic heading. But if it's 3.5 degrees west, then you will add that to your true course to get your magnetic heading. So if it's east, it's least. If it's west, it's best. So in this case, we'll add our, there I go, we'll subtract 3.5 degrees east from our true course to give us our magnetic heading. So we'll just go ahead and do that right now. So let's just say calculator. So let's just say, and I could mental math this real quick, but I'd really like to show the processes right here. So let's say 144 degrees minus 3.5 degrees gives you a magnetic heading of 140.5 degrees. So what does that mean? Well, that's your magnetic heading. All that simply means is that, and I'll go ahead and take the sectional off real quick. All that simply means is that if you were to jump in your airplane and fly your magnetic heading of 140.5 degrees, it will take you down the true course of 144 degrees. And that is how you take variation into account. That's simply all it means, but it doesn't mean that your flight plan is done yet. It just means that you've taken variation into account. There's still a few other things you have to take account for your eventual compass heading. That is just one of the many things you have to, though. Okay, so let's continue on. So hopefully you're getting a little bit of a better idea of what variation is. We'll just do a few more examples. And what I'll do, I think, is I'll just go ahead and get out of my comfort zone here, and I'll just completely pick something so off the wall that so let me go and take the sectional chart off. Let me go and zoom out, and let us go to California. Okay, right here. Never been to California. My sister did go to college there, but I didn't. I went to community college, and then I went to other colleges. So let's just say I'm here, and I have absolutely no idea where this is at, but I probably should. And let's just go ahead and load up the sectional for this area. And while it is loading up, okay, so essentially, let me just plan a really simple flight here, okay? Let me just say, that's Vandenberg, that's Guadalupe. Let me see, let me go ahead and, there we go, that'll work. That's a whole lot better. Clear that out. Okay, let's say I want to go from San Luis here, never been there, but let's just say I want to go to San Luis to Santa Maria, Hancock. And what we'll do is later on we'll do a bigger video about looking at sectionals and stuff like that. But for right now, all I'm concerned about is variation. Now what I'm going to do is I'm going to look for my isogonic line right here. And it looks like we have one right here. Okay, so that's about 14 degrees east. Let me see if there's another isogonic line I should use. Doesn't really look like there's another one out there. So I'll just go and use my 14 degrees east right here. So 14 degrees east, that means I subtract that from whatever my true course is. And this tells me that I have a true course of 155 degrees. So 155 degrees minus 14, gives me a magnetic heading of 141 degrees. That's pretty significant right there. To give you an example of where this is, or here's a little trick that we can talk about. If you ever wanted to find out exactly where your magnetic north converges as, because these are what your isogonic lines are eventually converging at, your magnetic north. One of the tips you can use is to look at your VORs. Now your VORs are actually set to your magnetic north as far as your radials are concerned, because you navigate by your compass and you want to be able to use them. So your VORs are always going to have needles pointing towards your but your magnetic north. So if we were to just kind of give an example of the variation here, let's say I were to draw a line to my geographical north pole. So we'll start at the VOR and we'll do it exactly 360 degrees right there. And then let me draw another line from here to my magnetic north pole. Okay, let's go and take the sectional off. And that is your variation right there. That is your difference between your geographical north pole and your magnetic North Pole. This line, this distance right here, is your variation. So it's very important that you take that into account. I'm going to go ahead and stop the video right here, and I'll continue up on the next one.